Integrals Part 4, Common Integrals. These are some that you're just going to need to remember. We already came up with one of them, which was the integral of 1 over x dx is equal to the natural logarithm of x plus a constant. Um, During calculus class, you'll learn how a lot of these things come about. Here, I'm just going to list out the ones that are important. These types of integrals can be found in integral references like the front cover of your calculus textbook or online. So in all cases in physics class, if you run into an integral and you need to know how to do it, you can always just try and look it up. That's a perfectly acceptable technique because we're mostly interested in what the answer is, not in the process of getting there. Calculus class is going to be very much interested in the process of getting there. So make sure that you pay attention in calculus. The integral of sine of x dx is equal to negative cosine of x plus a constant. The integral of cosine of x dx is equal to sine of x plus a constant. These are all common ones that we're going to need to know. Thing to remember is if you can't remember an integral but you know a derivative, if you know the derivative of sine is cosine, then you know the integral of cosine is sine. These things work in patterns. They work in pairs. The derivative of cosine is minus sine, so the integral of sine must be, that minus sign still has to be there, must be negative cosine. Um, the integral of tangent of x is an important one. The integral of secant of x dx is important. So we should find those. Let's see how how easy it is to find those integrals. And let's go hop over here to, for example, um, integral of tangent x. See if it's out here somewhere. Integral tangent of x. And see, you'll see that there's references to here. Um, they actually show you the technique by which you get the integral using a u substitution. Um, but you'll notice that the integral of tangent of x is equal to the natural logarithm of cosine of x. Okay, let's look up the integral of secant of x. And here again, you can see that they do it for you, and you get an answer that it's the natural logarithm of secant x plus tangent x. So it's important that you realize that a variety of integrals are available to you as already solved, already online. Um, and so finding that having to be able to do them in our context is not entirely important. You just have to recognize that if you get stuck and you see that you have to do the integral of secant of x, go look it up. These over in this left-hand column, though, are ones that you'll run into enough that you should simply remember them. A couple others that are in the really easy column are the integral of e to the x dx. This is the easiest integral out there because the answer is e to the x. So it is itself. And if you had, for example, the integral of e to the ax dx, this is equal to ae to the ax plus c. I think I just got that wrong. I just wrote the derivative, not the integral. So let's back up here. And it's really 1 over a e to the ax plus constant. So there's some that are particularly simple. Those are the ones that we're going to worry about. Now, beyond just the simple integrals that you have memorized, we have to learn a few techniques on how to integrate. So the first technique is called u substitution. U substitution is sort of like chain rule. When we did chain rule, we learned that the derivative of a function is equal to a combination of rule. Here we're going to be looking at what is the integral of a function that contains some other piece inside of it. And the idea here is that if I have an integral of, let's say, for example, let's do that one for tangent above, sine of x dx all over cosine of x. Here we see that we can recognize that part of this integral is the derivative of another part of this integral. So for example, we know that cosine of x is the derivative of sine of x, right? Or we know that sine of x is equal to minus the derivative of cosine of x. We can recognize that. How do we recognize that? We do enough of these and we practice. So that means that I might be able to rewrite this original equation by saying, let's let some variable equal cosine of x. And now I need to take the derivative of this. The derivative of this must be, derivative of cosine is negative sine x dx. Well, you'll notice that this stuff right here is what appears in my integral, which means that by making this substitution, my blue integral becomes the following red integral. It becomes minus du all over u, which I can now rewrite as minus the integral of 1 over u du. And what did we just learn? The integral of 1 over something is equal to the natural logarithm of that something. So the answer to this is minus natural logarithm of the absolute value of u plus a constant. But I can't leave this u because I wasn't given it to start with. I have to put what u was back in. So I come back to here and I see that I used u equal to this. I can substitute that in there. And so my answer of the integral of sine x dx all over cosine of x is equal to minus the natural logarithm of cosine of x plus a constant. And there I've just used u substitution in order to find what the integral of tangent is. Because of course tangent is sine over cosine, which I don't think I said at the beginning of this. U substitution is the most common integral technique. It's the first one you try, and the condition is that whatever I pick as my u substitution, so in this case I picked cosine, u is equal to cosine of x. Whatever I pick, when I'm done substituting it in to my original function, I have to have only that variable left. So in this case, when I was done here in this section, I had only u's left. I didn't have any x's left. If I make a u substitution and I do all my stuff and I have both u's and x's in it, that means that I either picked a bad substitution or the u substitution won't work at all. So you have to realize when you're on the right track or not. Now, beyond u substitution, there's many other types of integral techniques. You're going to spend a lot of time in calculus class learning what those integral techniques are. In our particular class, a major one that we're going to use, because of the types of integrals that are generated by the electromagnetic field problems, is trigonometric substitution. And a trigonometric substitution is sort of like a u substitution in that we can pick a portion of our integral to be a new variable. And then by making some mathematical substitutions, it makes the original integral much simpler to do. And so that'll be a topic for another video.